During this quarantine, I actually had the chance to watch some of my favorite movies all over again. One of them being Batman The Dark Knight. And people often say that Batman is the most realistic superhero. However, there are quite a few scenes that I found that were unrealistic and straight out defy the laws of physics. In this scene that I'll be talking about today, Batman, also known as Bruce Wayne, hosts a party at his house when Batman's arch nemesis, Joker, crashes the party. As he erupts, Batman beats up all his thugs, and then it's just Joker left all by himself. Joker, being the smart guy he is, takes Rachel hostage and throws her out the window. Batman, being the superhero he is, and also since he has a close relationship with this person, jumps out of the window to save her from a very, very tall building.
Let her go.
Very poor choice of words.
Let's not do that again.
As you can see, this is highly unrealistic. Not only are the two characters still alive, but they are beginning to talk afterwards. I will now prove, from a physics point of view, why they should have died. To find this out, I will first need to draw a free body diagram. Once I've drawn my free body diagram, I also need to make down positive because that's the direction they're going to, and it'll be easier to do my equation. Also, Rachel and Batman are falling down together, so they'll be falling down as a system. And since my FG is equal to MA, my FNet would be equal to MA. So now I just have to find the masses. To find the masses, I searched up the actors for the cast of the movie and got their masses in real life so that this equation could represent a more realistic point of view. After getting their masses, I put their masses into the equation, and they have a total force of 1,409 newtons. Using Newton's third law, since Batman and Rachel exert a combined force of 1,409 newtons, the car exerts that force back onto their bodies, which leads to them being dead because of the pressure that it amounts on their bones. Today I'll be talking about the movie Gone in 60 Seconds, the 2000 remake, and a bad physics movie scene from this movie. In this scene, Nicolas Cage is on a bridge trying to evade the cops. He's trying to evade the cops because he has stolen the 50th car in order to save his brother's life. And he'll do whatever it takes to steal his car and deliver it. So with the cops behind him creating a roadblock, and the right lane is completely blocked off because of a traffic jam that happened due to a car crash, the only way out of this situation is a ramp on the left lane. So Randall chooses to actually go straight and go on over the ramp, which goes over tons of cars, and it's really unrealistic how he goes over the ambulance.
Get out of the car, man! Brains!
Since this is a type 3 projectile motion question, I will have to make sure that I have the velocity, time, and the distance in order to conclude my answer to see if this is physically possible or not. To find out the speed that the car is traveling at, there's actually a clip right before he goes onto the ramp of the car traveling at 94 miles per hour. However, when he goes up the ramp, it's estimated that that speed would slightly decrease a bit as he is going to drive uphill. So I used 90 miles per hour and then converted that into meters per second. To record the amount of time that Nicolas Cage was in the air for, I started recording my stopwatch as soon as his front wheels left the top of the ramp, and then stopped it as soon as his front wheels reached the road again. Once again he landed. So I did this 10 times, and then I found out the average, which was 7.5 seconds. To find out the angle of the ramp, Mr. Kasha helped me by using some digital analyzing software to find out that the ramp actually had an angle of 65 degrees. To find out the height, I referenced a frame where a person was standing next to the ramp. An average American male is 5 foot 10 inches, which translates over to 1.77 meters. I also found another frame where there was a tow truck right beside the ramp that was a little bit taller than it. I searched up the model and I got 2.08 meters for that. To account for the differences in the height for both of these references, I then made the approximate height 1.9 meters for the ramp. To determine the total distance that the car traveled in the air, we need to find out how many cars there are in between the position where he went off the ramp all the way to the landing position. To do this, we first see that he goes over a police car in the first frame. And then in the second frame, we assume that there's another car in between the police car and the first car in the second frame. That brings us to a total of 3. Accounting for the other cars in the other frames, we have a total of 9 cars so far, with the average car length of 16 feet, which gives us 144 feet in total. There's also a fire truck right after these cars, which the length of the fire truck is 35 feet. There's also another ambulance in front of the fire truck, which has an average length of 26 feet. And since there's a gap between the ambulance and the fire truck, we're assuming that there's 5 feet of space in between them. Adding all those values up, we bring our total distance to a total of 210 feet. In order to put this number in the equation, we need to make it into meters, so it turns into 64.01 meters. To find out the vertical velocity and the horizontal velocity, we must draw a triangle to represent the incline as well, so that we can use the Pythagorean theorem to find out these certain velocities. After these velocities are found, I'm just going to put it into my equation to find out the change in distance. And I get an answer of negative 2.145 meters. So this proves that this is impossible, because this would mean that the car would go under the bridge, because we're looking at the bridge as 0. And anything that's negative would mean that the car would actually go lower than landing on the bridge, meaning that gravity would push it down to an extent where it can't even go over the ambulance or over those cars. It would just fall down, therefore making this impossible. This next equation shows what you would need for your velocity in order for the car to land after it's gone over the cars onto the bridge. So we get an answer of 36.496 meters per second as our vertical velocity. This is slightly greater than the velocity that we're going at, which is 36.464 meters per second. Therefore, proving that we need to go faster in order to land there. However, this does not mean that the car will go over the ambulance at the very last step. This is highly unlikely, because the ambulance is actually higher than the original ramp that the car took off at. And this is the last part of the projectile motion. The car should be dipping down before it even approaches the ambulance. This shows that the car should have crashed in the ambulance. Also, as the car is coming at 90 miles per hour when it lands, it's safe to assume that the car would not just be controllable, that the car would actually lose control, and the driver would most likely result in an accident. I ended up doing 2 movies instead of 1, because in Gone in 60 Seconds, the driver actually didn't make it by a very, very thin margin. If he was going just a little bit more faster, he could have potentially made it. Therefore, I chose to do another movie, because in the first movie, Batman, there's no way that he would survive that, even if he was going a little bit faster or slower.